Assalamualaikum and good afternoon to our lecturer, Dr. Muhammad Shazwan bin Muhammad Sanusi. So today I would like to present our lab report. The chapter is Characteristic Curve of Semiconductor Diode M4. So this is my group member. Firstly, myself. My name is Farhana binti Muhammadin. Second, Kang Kajwan, and the last one is Hana Rifkah binti Muhammad Ghazali. The objective for our experiment is first, to study the properties of semiconductor. Second, to determine the characteristic curve of semiconductor diode. So the apparatus that we use to conduct this experiment is potentiometer, DC power supply, bundle of connecting wires, 3 diode which is 4000 series diode, LED and Zener diode, and millimeter, and the last one is voltmeter. So this is our procedure. First, the circuit was set up as shown in figure 4 using a power generator, a potentiometer R, DG ammeter, DG voltmeter, and diode 4000 series. Second, the current passing through the diode was changed by means of potentiometer. The current was slowly increased till it reached saturation value. Third, the current and corresponding voltage across the diode was read for forward bias and reverse bias. 20 point of I versus V was recorded in table 1. And the last one is step 2 and 3 performed above the LED, and Zener diode was repeated.
This is the data we obtained based on the experiment. This is for Zener diode. This is for LED. And this is for diode 4007. A curve of the diode current I versus its voltage is plotted. This is the graph for diode, Zener diode. We can see that there is forward bias and reverse bias. This is for LED, and the saturation current can be obtained at this point, which is where the lines start to be straight. While this is for diode 4007. Task 2, we are asked to get the saturation voltage. We can get the saturation voltage from the graph, which is where the lines start to be straight. For Zener diode, the saturation voltage was 0.655 volt, for LED is 1.766 volt, and for diode 4007 is 0.605 volt. By using the equation 1 given in the theory part, we are asked to determine eta, the ratio of the current in the diode for the saturation voltage, and I0, and we use least square method to solve this task. This is the data for diode Zener. Based on the equation, we plot a graph ln I versus V. By using least square method, we find the centroid, and then we get the gradient and the y-intercept of the graph, and also its uncertainty. Based on calculation, we can get an equation. Based on equation 1, we learn both sides and neglect 1 because the value for I0 is very small, so we can neglect it. And then using the equation we obtain from least square method, and then we will get the formula to calculate eta. And then we sub in the value, and then finally we get the eta for Zener diode is 1.42, which is reasonable because it is between 1 to 2. And then again we use the equation obtained from the least square method to get I0. And then I0 for Zener diode is 4.38 times 10 power of negative 12 ampere. And this is the data for calculation for LED in least square method. And this is the graph ln I versus V for LED. We can get a straight line here. And this is the equation for this diode. And then we do the same. We use least square method to get the equation. Then we sub in the value obtained from least square method, and we get the eta for LED is 2.19. There's a slightly different for this LED. This may be due to experiment error. And again, this is the data value for diode 4007 in least square method. And this is the graph long I versus V for diode 4007. The same we get the straight line. And then we use least square method to calculate the equation for the gradient and y-intercept and also its uncertainty. Based on the calculation, we get eta for diode 4007 is 1.75 and the uncertainty is 0.05, and this is also reasonable because it is between 1 to 2. And the saturation current is 9.75 times 10 power of negative 10 ampere, which is small. So how a diode works? A diode is a unidirectional electric component which allows current to flow in one direction. So it's a semiconductor which consists of p-type and n-type. We can see here. And then there's a junction in between p-type and n-type. When the electron diffuse across, it will combine with hole and depletion region will form. Forward bias will occur when the positive terminal is connected to p-type while negative terminal is connected to n-type. In this case, the width of the depletion region will decrease, so current is permitted. For reverse bias, we change the terminal, where positive terminal of battery is connected to n-type and the negative terminal of battery is connected to p-type. So the depletion region will increase and the current cannot flow through. Based on the finding from internet, I get that the infrared LED has 1.14 volt for typical voltage and red color has 1.76. The highest typical voltage among this is green LED, which is 1.96 volt. Based on the experiment, the conclusion I obtained is Zener diode can conduct both forward and reverse bias. While when the Zener diode reaches zero voltage, the voltage will remain constant, although we still increase the current. In forward bias, the voltage will increase when the current increases.
The discussion is the graph of IV curve of semiconductor are plotted for Zener diode, diode 4007 and LED. In forward bias, we can see that saturated voltage for Zener diode and diode 4007 are 0.655 volt and 0.605 volt. Saturated voltage for LED is 1.766 volt. And it is very close to the exact saturated voltage of LED, which is 1.8 voltage. Red LED that made up of gallium doped with phosphorus and arsenic has a bandgap energy 1.8 electron volt that will emit red light. The characteristic curve in reverse bias is not obtained due to the insufficient of reading. This may be caused by the limitation of the potentiometer as there are no increment in voltage and current. The material constant for Zener diode, diode 4007 and red LED are 1.42, 1.75 and 2.19. Zener diode and diode 4007 have material constant that are close to the material constant of silicon. LED has different value of material constant due to the different composition compared to Zener diode and diode 4007. While doing the experiment, the reading from voltmeter and ammeter are having fluctuation due to the capacitance effect set up across the PN junction. The oscillation of capacitance causes the reading to be fluctuating.